For many years, the story of artificial intelligence was straightforward. Progress meant building larger models, training them on more data, and running them on increasingly powerful chips. When computing limits became a concern, attention shifted to energy consumption and memory constraints. But today, a different bottleneck is quietly becoming decisive. As AI moves from experimentation into large-scale deployment, connectivity is becoming just as important as computation. It is no longer only about how fast a chip can compute. It is about how efficiently thousands of machines can communicate with one another. Modern AI systems do not run on a single computer. They run across entire data centers. And when communication slows down, the entire system slows down. Hi, I'm Freeman. I've been a firm believer in the AI revolution for many years, ever since I first saw its real-world capabilities at the EM Tech Asia conference in 2018. At that time, AI was already demonstrating voice and facial recognition, autonomous driving, robotics, and intelligent systems that far exceeded what I had imagined was possible. What struck me was not just how impressive the technology looked, but the realization that we were entering a fundamentally new era. That experience shaped how I invested. I began allocating capital to early AI adopters and beneficiaries, particularly Alphabet or Google, and later Microsoft and NVIDIA. In hindsight, those investments paid off as AI moved from promise to mainstream deployment. Today, many of the obvious winners are widely recognized. Much of the early re-rating has already taken place. That naturally raises a new question. Where is the next constraint, and therefore the next opportunity? Before we go further, a brief disclaimer. What follows reflects my personal views as an investor. It is not financial advice or a recommendation to buy or sell any securities. I strongly encourage you to conduct your own research and due diligence before making any investment decisions. Increasingly, I believe that the next AI opportunity lies in connectivity. When people interact with AI, asking questions, generating content, or using AI-powered applications, that phase is known as inference. Unlike training, which happens periodically, inference runs continuously. It operates all day, serving millions of users. Behind the scenes, inference workloads require thousands of servers to communicate constantly. Requests move across multiple machines before returning an answer. This internal communication inside data centers is massive and continuous. To understand this, imagine a city's highway system. If traffic flows smoothly, people arrive quickly. But if there is congestion at every junction, even small delays add up. In AI systems, those delays are measured in microseconds, tiny fractions of a second. But when they accumulate across many steps, users begin to feel slower responses. In this environment, consistency matters more than peak speed. It is not about how fast the network can perform in perfect conditions. It is about how reliably it performs under heavy constant load. This is where connectivity becomes critical. In high-performance data center networking, only a few major players operate at global scale. Companies like Cisco, Juniper, and Arista all build high-speed Ethernet switches capable of handling AI workloads. The difference lies not in whether they are fast, but in what they prioritize. Cisco traditionally focuses on broad enterprise integration. Juniper emphasizes automation and operational simplicity. Arista, by contrast, has focused intensely on predictable, low-latency performance in large-scale data center environments. In small deployments, these differences may not matter much. But in hyperscale AI environments, where thousands of machines must coordinate constantly, small performance differences can become meaningful. Arista's design philosophy has been centered on ensuring that network traffic moves quickly and consistently across data center fabrics. Instead of optimizing for every possible enterprise feature, it has concentrated on performance under sustained load. For inference workloads, where responsiveness is key, this alignment matters. This focus has helped Arista gain share among large cloud providers building AI infrastructure. In environments where latency consistency affects user experience, the network becomes strategic infrastructure rather than background hardware. Arista's competitive advantage is not just about hardware speed. It is also about integration and operational familiarity. Its operating system runs consistently across its product line, allowing customers to manage networks in a uniform way. Over time, teams build automation tools, monitoring systems, and workflows around that platform. Replacing a core network vendor in a large AI fabric introduces risk. Performance behavior may change. Operational processes must be rewritten. In latency-sensitive environments, that uncertainty carries real cost. As a result, once deployed at scale, network platforms tend to be sticky. This combination of performance alignment and operational familiarity forms the foundation of Arista's moat. Financially, the company's performance has reinforced its strategic position. Revenue has grown from roughly $3 billion in 2021 to over $9 billion in 2025, representing sustained annual growth around 30%. Operating profit has expanded even faster, reflecting strong operating leverage. Profit margins remain close to 40%, which is unusually high for a networking hardware company. While there has been slight margin compression recently due to increased AI-focused investment and hyperscale deployments, profitability remains robust. Importantly, Arista carries almost zero interest-bearing debt, and its liabilities are largely operational obligation. It holds substantial cash reserves, which exceeds its total liabilities. This provides resilience during industry cycles and flexibility to invest in new platforms. A strong balance sheet reduces financial risk and supports long-term strategic execution. At approximately $129 per share, the stock trades around 38 times forward earnings. That valuation assumes continued strong growth, but it does not appear excessively speculative. Using a moderately optimistic discounted cash flow model, assuming 20% annual free cash flow growth over 7 years, a 10% discount rate, and a 3% long-term growth rate, the estimated intrinsic value is $128, close to the current market price. This suggests the stock is roughly fairly valued under reasonable growth assumptions. It is not deeply discounted, but it is also not priced for unrealistic hypergrowth. As always, valuation ultimately depends on whether the company can sustain its growth and market share gains. As artificial intelligence moves into its deployment phase, inference workloads are becoming dominant. These workloads are interactive, distributed, and continuous. In such an environment, latency becomes a structural requirement rather than a secondary concern. If connectivity becomes the defining bottleneck of AI infrastructure, then companies that enable predictable, low-latency performance stand to benefit structurally. Arista is positioned at that intersection. Whether it represents an attractive investment today depends on one central question. Can it sustain its growth long enough to justify its valuation? Personally, I remain cautiously optimistic. But as always, this reflects my own perspective as an investor, not financial advice. I encourage everyone to conduct their own research before making investment decisions. Goodbye, and have a great day.